Okay, so we're going to continue with 3.8. Algebra 2, Mrs. Katzer. This is function notation. Okay, so we're used to regular notation, which is y equals 5x plus 2. Okay, we're used to that. We have graph lines using this. Okay, the way we say it, y equals 5x plus 2. Okay, what may be new and what may not be new is function notation. Okay, so this is f, and then we have a parentheses x equals 5x plus 2. And the way we say this is f of x equals 5x plus 2. So similar to the last one, instead of saying y now, we say f of x. Okay, arrow notation is very similar. Okay, so for this time we have an arrow in place of the equal sign, and we have a colon in place of the parentheses. But we say this the same way. So f of x equals 5x plus 2. Okay, so let's go into an examples. Example 1. List the range if, okay, and I have this function, and this is what they gave me, f of x equals 4x minus 3. So this is what you'll see on your homework. And then we've given a domain of 0, 1, 2, and 3. Okay, this other stuff down below, that's what we write after. Okay, so f of 0, meaning what I'm going to do, 0, I'm going to substitute. Do you see how 0 is in the place of the x in the our function there? So our domain is 0, 1, 2, and 3. Notice over here in the parentheses I have 0, 1, 2, and 3. Okay, so I'm going to replace x with 0. So the same thing goes for the function, okay, or the equation here. Okay, so instead of having 4 times x, I'm going to have 4 times 0 minus 3. Okay, I'm going to continue this to figure out what it is. 4 times 0 is 0 minus 3. Okay, that is also equal to negative 3. Okay, so that negative 3, that is part of my range, right? So I plugged it into the function, and now I have the output. Okay, so the input was 0, the output is 3. The output is the range. So I'm going to do the same thing for 1. Right, put 1 in the place of x, so 4 times 1, right, 1 is in the place of x right there, minus 3. Okay, I'm going to continue to solve, so this is 4 minus 3 equals 1. So this is the second number of my range. Okay, and 2, so I'm going to plug in 2. 4 times 2 minus 3, okay, so this is 8 minus 3, which is 5. Okay, so 5 is the third number of my range, and I still have to plug in 3. Okay, 4 times 3 minus 3. So this is 12 minus 3, which is equal to 9. So all these numbers over here, negative 3, 1, 5, and 9, those are all part of my range. Okay, I already have the R pre-written over here, and it's a solution set. So I'd put my braces, and so I'm going to put it in order. And actually, they already are in order. Negative 3, 1, 5, 9. So negative 3, comma 1, comma 5, comma 9. Okay, that is my range right there. So right there is my answer. All right, so let's try another one, because they do get more complicated. However, this one is just another example. Notice this one is g of x. It's the same thing as f of x. It's just using a different letter. Okay, so again, we're going to do the same thing. Okay, this is what we're given. We're given the function, and we're given the domain. We're finding the range. So we're going to do the same thing as last time. Okay, so g, instead of putting x, I'm going to put the 0, 1, 2, and 5. So g of 0 equals, I'm going to replace the x with 0 as well, 2 times 0 minus 1. All right, so this is 0 minus 1, which is negative 1. So negative 1 is our first answer. G of, we have to plug in the next number, 1. Okay, so 2 times 1 minus 1, this is 2 minus 1, which equals positive 1. Okay, plug in the next number, g of 2. Okay, 2 times 2 minus 1, this is 4 minus 1 equals 3. Okay, and the last number, g of 5. Okay, plug in 5, 2 times 5 minus 1. So this is equal to 10 minus 1, which is equal to 9. Okay, so right here I have my range equals, put a solution, braces, negative 1, 1, 3, and 9. Okay, there's our answer. That is our range. All right, so let's do the next one. Okay, so we're going to find the values of the given function with the set of real numbers as the domain. So we don't really have to worry about the real numbers. It's just saying like this is a perfect function. Okay, there's not going to be anything we can't put in there. So g of x equals 5x minus 9. Okay, they say find g of 3. That's my a. Okay, meaning we're going to plug in 3 just like we did in the last ones for x. Okay, so this is 15 minus 9, which gives us 6. Okay, that's my answer. I'm going to circle it. Part B, find g of negative 3. So plug in negative 3. 5 times negative 3 minus 9. Okay, that is negative 15 minus 9, which gives us negative 24. That's my second answer. Okay, g of negative 8. So this is 5 times negative 8 minus 9. All right, so negative 40 minus 9, which is equal to negative 49. So those are my answers. That's very different from the last one, right? The last one I wrote or equals and then a braces. And then this one I just have the answers are just circled in circles, like any normal problem we've done previously. Okay, so example 3, find the indicated values given. We have f of x equals 2x minus 1 and g of x equals x squared plus 1. So this is slightly different. Now we have two functions. Okay, but we're going to do the same kind of thing. So f of x equals 2x minus 1. Okay, we're going to take this f, we're going to find f of 2. Oh, well, I didn't have to write that. 2 times 2 minus 1. I'm going to work down for this one. 4 minus 1, so this answer is 3. So my answer for A is 3. Right? So for the next one, g of 2, we're going to use the g function. Okay, so I'm going to plug in 2 for the x. So 2 squared plus 1, right? That's for my g function. So 4 plus 1 is 5. So 5 is my answer for B. F of A. Now that's weird. Okay, that's not a number, but that's nothing we can't do. Okay, that means I'm going to replace x with A. So this one's even easier than the other ones. So 2A minus 1. Okay, nothing else I can do there. For D, F of G of 2. This G of 2, we have to do that first. Okay, so if we're following our PEMDAS, which is the order of operations, or please excuse my dear Aunt Sally, we do what's inside our parentheses. Our parentheses tells us to do G of 2 first. Okay, so let's find G of 2. Oh, we did it already. It equals 5, right? So it equals 5. That was our part B. Okay, so we're finding G of 2. So if G of 2 equals 5, so now we have to find, I'm going to plug in 5, or substitute 5 for G of 2. So really, they're telling you in a kind of like fancy way, find G of F of 5, right? So we're going to plug in 5 now. So for F, so that is the F of 5 is going to equal 2 times 5 minus 1. And that's coming from my F function up there, okay, up here for my F function. So this is 10 minus 1, which is 9. So my part D is going to be 9. All right, so let's do another one. Okay, so this one's even harder. We have two functions. Find the indicated values given. G of 1, okay, meaning I'm going to plug in the 1, right? So this is going to be 2 plus 1 squared. Don't forget to do the right function. This one is G. Okay, so that is 2 plus 1, which is 3. So that answer is 3. Now I'm finding G of F of 3. So the same thing as last time. I have to do my F of 3 first. Okay, so let's find F of 3. Okay, so this is 5 times 3 minus 1, 15 minus 1, which is 14. All right, so now I have to plug that in. I'm going to go down a little bit so we can see everything. Okay, so now I have f of 3 equals 14. So really, again, fancy way of telling you, find g of 14, making you do extra work. Okay, so this is 2 plus 14 squared. Okay, so this is 2 plus 196, I believe, which is 198. Okay, so that answer is 198. So let's do the next one. F of g of 0, meaning, right, we do the g of 0 first. So plug in 0 for the g. So g of 0 is going to equal 2 plus 0 squared, which is equal to 2. Okay, so g of 0 is 2. So now let's find f of 2. Replace the g of 0 with 2. F of 2 is going to equal 5 times 2 minus 1. That's a parentheses right there. 10 minus 1, which is equal to 9. Okay, so that is how I do these problems. Functions. Okay, good luck on your homework.